Hi and welcome back. So in the previous video, we have learned how to encrypt and decrypt a text. But in this video, we are going to learn how actually to encrypt a file and then decrypt it back. So let's go to the AES service class, write suspend function, encrypt file, and as a parameter, we will have input file of type file and output file also of type file, and then the key of type secret key, and we will return a nullable file. So we will give the input file as the original file, and the output is going to be the file that we are going to convert it to the encrypted file. And if it was successful, we will return the output file as the return type of the function. And then same goes for the decrypted function. So decrypt file is going to get the encrypted file of type file, and the output again of type file, and the key of secret key. And it also will return the nullable file. So let's go to the implementation class, import these two functions. Again, we will use with context and dispatchers.io, since we are going to work with file here, and return a try catch block. In case of any exception, we wanna print stack trace and then pass null. But for now, let's create a dummy file here to get rid of this red errors everywhere. So first thing that we need to do is to add our security class a provider called bouncy castle provider, a new object of it. And then we are going to init our cipher again to cipher.encrypt mode and also pass the key to it. So the IV is going to be cipher.iv, and then we will create an input stream of our file, which is going to be file input stream of type input file, and also an output stream, which is going to be file output stream, and pass the output file to it. And we will also have a cipher output stream, which is going to be cipher output stream of JavaX crypto, and pass the output stream and cipher to it. And then we will choose a buffer of type byte array of length 1024, and we will start reading buffer by buffer from our input stream, like this. Input stream dot read, we will read a buffer, a chunk of 1024, and also bytes read, which I haven't created, a var bytes read of type int is equal to it, and this file will be on until the value that is being read is greater than -1. So using this file, you'll write each buffer from index of 0 onto cipher output stream, just like that. And after that, you'll close the cipher output stream, and then also input stream dot close, and then return the output file. But you can see I haven't wrote this IV in the beginning of the file. So using output stream, I have to write this IV to the output file. So the first beginnings letters or bytes of our output file is going to be our IV. Then we can separate it later back to decrypt our file. So let's go to the decrypted file function. It's going to use with context again with the IO dispatcher, which is responsible for working with files. Again, we will return with a try catch block. In case of any exception, we wanna print the trace and then pass null to it. But here we'll just return the simple file here to get rid of these red lines everywhere. Again, we wanna add the security, a provider called bouncy castle provider, and then create an encrypted data input stream. It's going to be file input stream and encrypted file, which is going to be input of it. And then we will create a byte array using our IV length, and it's going to be byte array of size IV size. Then we will separate the IV from the input stream, which is going to be encrypted data input stream, and we will write it to the IV byte array and the index of 0 and size of IV size, just like that. So in this line, we just separated the IV from the whole encrypted file size. So we have the IV here, and then let's initialize our cipher again to the cipher.decrypt mode, pass the key and also IV parameter spec, and pass the IV to it. So that's why we prepared IV here and extracted from the bytes that we recently added to our file at the beginning. So we know there's 60 characters, there's 60 bytes of IV wrote on the output file, and then here we'll extract it using index of 0 and the IV size. So our IV is ready to use, and our cipher is set to decrypt mode also. So it's time to create the output stream here, which will be file output stream, and pass the output file to it. And also we are going to create cipher input stream this time, which is going to be cipher input stream of javax.crypto, and pass encrypted data input stream and cipher to it. And again, I'll create a buffer of type byte array 1024 and create a variable called bytes read of type int, and create a while cipher input stream read. We'll pass the buffer to it, and also bytes read is equal to it, and it will go on till it's not equal -1. And then using output stream, write each buffer that we read before from index of 0 and pass bytes reads to it. And then close all the streams, output stream dot close, and also cipher input stream dot close, and then return the output file. Okay, so let's go from top to bottom again. We have two functions, encrypt file and decrypt file. So what happens inside this function, we will switch to IO dispatcher, which is responsible to work with files. We will create a try catch block to return null in case of any exception. And inside here, we will add the provider to our security, bouncy castle provider. And then we will initialize our cipher to encrypt mode and pass the key that we are going to work with. Then we will have some initial vector, and we will create our input stream and output stream to read the file from input and write it to the new file. So the first thing that we do, we always write the 16 bytes of the IV on the first of the file, and then create and cipher output stream, which is responsible for encrypt each packet and write it inside our output stream. That's all it does. So we will chunk actually our file into the byte arrays of 1024, and then using a while loop, we will start reading from the input stream, and using cipher output stream, we will encrypt and write it inside our output file. After that, we will close all the streams and then return the file. And same goes for the decrypt file. We will first extract our IV from our whole file. We know it's 60-digit byte array at the beginning of each file. First we'll extract it and then initialize it to decrypt mode. And as you remember, you have to pass the key and IV parameter spec inside that CBC padding. So after extracting the IV, we will initialize our output stream and also cipher input stream to decrypt each chunk and write it inside our output file using this file. You can see cipher input stream, we will read each buffer, decrypt it, and using this file, we will write it inside our output stream. Then close the streams and return the output file. Okay, so to test this, we will copy and paste some codes here. Let me remove the extra stuff here. So we will have our key here, and then we are going to use a file picker launcher up here, and using onStart method, I'll copy and paste this one, and also this file helper class. So using this file picker launcher, we will start an intent to pick a file, and in case of returning any URI, I'll extract the file name using this file helper class get file name, which is a query inside our content resolver, and then we'll get the file name of it, and then create a file using create catch file from URI using this class again. And then this is our file to encrypt, and we have a file ready to encrypt. So I'm going to pass this file picker launcher to this greeting composable, and using this onClick button, I'll launch this launcher object. I'll wanna launch an instance to open any file like this. Remove this coroutine block. So right here, if we launch the launcher and open a file, this will get notified and the file will be ready here. And then using this session, I'll create a AES service is equal to session.get AES service. And down below, we are ready to work with our file. So let me copy and paste it here like this. So we will have a path to encrypt. It's going to be this URL, which provides our downloads directory, and create a file using this file name and with the suffix of .enc, which stands for encryption. We'll create a file using this path to encrypt, and we check if this file to encrypt is not null, then we will open a block using dispatcher.main. We know later we want to switch to IO dispatcher using this encryption function. If you guys remember, you will see that we are switching to IO dispatcher, so it should be work pretty fine. And for the key, we will create a key up here, private val AES key is equal to AES service dot generate key with length of 128. So I'll pass AES key here to encrypt this file. So we have a file here, and then we wanna encrypt it using this path. So we check if this file is not null. First, we will encrypt this file using encrypted file, which is going to be using this file that is going to be our target to encrypt it. And this encrypted is actually our encrypted file. So after that, we will create a decrypted output, which stands the same as the encrypted path to encrypt. So we will going to reverse the whole process. So we will create a path to decrypt the file that we recently encrypted before using OS download directory, and give some prefix decrypted with some random digits to it, and give the file name to it, and create that file using the path that we just created, and using the AES service dot decrypt file, and pass the AES key that we know they are the same, and using this log t, we will get the path of the decrypted file. So we can use it again and mark it decrypted file path, and same goes for encrypted file path, encrypted.path. So we will log the encrypted and the decrypted file path. So let's run our emulator and check if it's everything working fine. Let's clear the log. I'll check if I have any file here. Nope, I have to download some. So I just downloaded an image of a tree. If I click it here, you'll see encrypted file path is images.jpg.enc. You will see we concatenated .enc to it, and the decrypted file is here, decrypted -0a14 image.jpg. So everything is working fine and well. So that's it for encryption and decryption using AES feature. Till the next video, see you everyone.